Okay, so as promised, I'm going to do another video going through the practical just to give you a little bit more kind of reference for your project. And this practical is basically going over correlation and regression, and just with what I think is quite an interesting data set. So what we have here is we have some wines, we have red wine, we have some red wines, and we have some white wines. And then we have some various attributes of the wines. Now, I don't know enough about wines, but there's things like the acidity, residual sugar, etc., with the amount of alcohol. And then we have the quality of the wine. Now, most of our predictions are going to be utilizing the quality of the wine. We're going to try and find out what makes a good wine. Now, this data isn't completely continuous, but for this class, it's really close enough that we can build some interesting models. And in fact, the original use of the data set was to predict whether a wine is red or white. But those sort of class prediction methods, you'd have to take my more advanced analytics class for that. Okay, so let's go through. This is kind of step one in the practical, and we go to graphs and we go to chart builder. And we're going to do a scatter plot. So as we've seen in class, scatter plots are all about looking at relationships. So we're going to do the scatter plot here. And what we're going to do is we're going to see if there's any relationship between pH and alcohol. So we're going to drag pH to the x-axis, and we're going to drag alcohol to the y-axis. And then we're going to look at the variety of wine in the color. So it's just a simple thing. So here we've got the graph. Now it doesn't tell us too much, it's quite a pretty graph. But we can see there's not a strong relationship between pH and alcohol. You can see that there's more, remember when we did the correlations, it's more kind of a cloud rather than closer to a straight line. We can see that the red wines are a little bit to the right of the white wines. But again, there's so many points, it's quite hard to see. But we could actually do a little bit more analysis of some of these things. So now let's go to, no, we don't want to tell IBM what we think of them. So we go to analyze, go to descriptive statistics, go to explore. And what we're going to do is we're just going to pretty much go every single variable. So we're going to look at the variety, and then that's the only kind of real categorical variable, and everything else is in the dependent list. And we're going to kind of keep the default statistics options, but for the plots, we don't want a stem and leaf graph. We just want a histogram. Because stem and leaf graphs, these are the kind of things you did at school. They're a bit messy with lots of data. So let's click OK. This might take a little while because it's just doing graphs for every single item of data we have. Okay, so there's lots of information here, but we can so you can see here, for example, and because we put the categorical variables in, we can actually see the difference from each of these values for the red wines and the white wines. So you can see the fixed acidity. The mean is 8.31 for red wines and 6.85 for white wines. So red wines are more acidic have more fixed acidity than white wines. And then we have the same, they also have more volatile acidity. And we have citric acid. Reds have a mean of 0.27 and whites have a little bit more citric acid. Now, I'm not going to bore you by going through all of these, but this is where kind of, you get the graphs are pretty useful. So for example, the fixed acidity, we can see the histogram here, we can see the distribution. We can see that the most wines, that it's not quite normal. The average, the mean and the median's around 7.5, but we can, and the mode as well, but we can see, there's actually a few wines that are very strongly acid. Here, the fixed acidity for white wine is much more normal. We don't have these very acid wines. And then quite nice, we can actually get a little box plot so we can see we can see the distribution for acidity is higher for red wines rather than white wines. And I kind of just, won't go through all of these. I specifically asked you in the practical to look for pH. So we just have to go through residual sugar, chlorides, chlorides, more chlorides, and we'll get there eventually. Here we are, pH. So we look at for the red wine, we've got the histogram, it's almost normal. Same with the white wine, but we can see that the pH is a little bit higher for the red wine than the white wine. So, generally do a data analysis. We look at some of these things, if we're trying to work out what's the difference between red wines and white wines, we could kind of look and think a little bit about the attributes of red wines versus white wines. So anyway, let's move on to our next thing is we're going to look at the correlations. So we're going to see which variables are related to each other. So we're going to do analyze, we're going to do correlate, and then we're going to do bivariate. And we can't have variety. In fact, we don't have that as an option because it's just categorical. But we're going to put basically everything else, and we're going to do a correlations. We're going to do all the default options. And here we can just see which have got kind of significant correlations and high correlations. There's actually quite a lot going on here. But let's just look at the last column. Let's just see what sort of things are related to quality. So we see that fixed acidity is negatively related, and it has a significant p-value less than 0.01. Volatile acidities, positively related with a significant p-value. Citric acid, positively related. Residual sugar, negative. Chlorides, negative. We got free sulfur dioxide, positive. Total sulfur dioxide, negative. Density of the wine is negative. pH is positive. And alcohol, it actually has the strongest correlation. So we find the higher quality wines have higher alcohol. So maybe the drinkers were a little bit more biased on this, or maybe the sample consisted of alcoholics. I'm not quite sure. So that actually, so if we're building a model to predict quality, we'd probably want to include alcohol because it's got the highest correlation, and it's got to 3 significant figures. The p-value is 0.000. So let's kind of get on to building our regression models. So we're going to start off with a very simple regression model. And we're going to do analyze, regression, linear. And because we found that quality had a high correlation with alcohol, let's just put in the independent variable is alcohol. And the dependent variable is quality. And I'm going to do some residual plots. So I'm just going to look. And I'm just going to use the dependent variable on X. And we're going to do some measure of the residual on Y. This is just saying, are the residuals changing, the errors changing as, we go along the regression as we get higher predictions of quality. And we're going to click OK, and we're going to click OK. So we can see here that our R is 0.444, R squared of 0.2. So about 20% of the variation in the quality is accounted for by the amount of the alcohol in the wine. That's not huge, but it's, there are lots of things probably going to wine quality. There's lots of high alcoholic wines which certainly are not quality. And the ANOVA overall is significant. And you see the alcohol, the coefficient is 0.325. So every additional percent of alcohol, so every increase of 1 in X, we get an increase of Y. The quality of 0.325 quality points, and it's significant. And the charts, don't worry too much about this because the reason this one looks weird is that because quality is not properly continuous, so we only have residuals for each whole number of quality. We can see the residuals tend to be increasing a little bit as our kind of quality increases, which is a little bit worrying because there shouldn't be any pattern. They should be normally distributed. But given the type of data, we won't worry about that too much. Okay, so now let's try and build my better model of wine. So I'm going to build a multiple regression. And I'm going to kind of just build it with multiple values. So as addition to regression, as addition to alcohol, I'm going to do, let me just get this, so analyze regression, linear. So I'm going to add the first 3 columns in addition to alcohol. So I'm going to do alcohol, And then I'm just going to pick these three, the acidities. And I'm going to click OK. And then I'm going to just keep the same plots as before. And I'm just going to click OK. So you see here now, our R squared has increased to 0.26. Remember, the adjusted R squared was the R squared, but accounting for how many predictors. So we just don't throw loads of error and noise and random predictors into the model. We still got a significant Hanover. And we see that alcohol is positive and significant. If we're taking alpha equals 0.05, fixed acidity is positive and significant. Volatile acidity is positive and also, negative and significant. And citric acid is negative and not significant. So if I was doing the task for the practical, I would remove citric acid and experiment maybe with some of the other variables that were kind of correlated with quality in the correlation and see if we could slightly improve this regression model. It's obvious alcohol is probably the best predictor, but we could probably maybe remove citric acid, and maybe fixed acidity doesn't have a very low significance. And by playing around, we could maybe get to slightly better regression, which was kind of the final exercise I had for you in the practical. Okay, so just to summarize, we did a little bit of graphing to look at the relationship between two variables. We then did correlations, and we used it to see, which variables are related to wine quality. And then we kind of used those correlations to actually put in a regression model to build this model of wine quality. And I mean, there's probably other things that are important. Things like the region the wine's grown in. There's probably other good factors you can use to actually predict the quality of the wine, that more business factors that are not included in this data set. But again, particularly if you like wine, this was actually kind of quite a fun data set. Okay, so that's it for the practical.